for example 7, here we're going to have partial fraction decomposition again. The only difference is in this problem, notice you have an x to the third, so when you actually do your factoring here, you're going to have 3 terms, which means you're going to have 3 sets of fractions from your decomposition. So that means that you're going to have denominators on the bottom, but you're also going to have an a, a b, and now a c on the top. So this one will take a few more steps, but remember your first one is you need to factor your denominator. Factor your denominator. So if we factor the denominator, we're going to end up with taking out an x, GCF of x first. So we're going to take out an x. Left over you get x squared minus 2x plus 1, which means you're going to have an x times x minus 1 times x minus 1, or an x times x minus 1 squared. Now here's kind of the tricky part, because these are going to be your denominators. You're going to have an x, you're going to have an x minus 1 squared, but you also have to break this up and say just one of these is an x minus 1. That's kind of the hard part to remember. So what you have to do is, next, we're going to have to multiply each of our numerators by your LCD. So if we multiply, I'm going to call it n of x, your numerators, by your LCD, and your LCD in this case is x times x minus 1 squared. So if you multiply your first fraction by x times x minus 1 squared, and your next fraction by x times x minus 1 squared, and your third one, you're going to notice that some things you're going to cancel. So we're going to cancel out your x's here. So that's going to give us an a times x minus 1 squared, plus in your second fraction, your x minus 1 on the bottom is going to cancel with one of these. So you're going to have a b times x minus 1. And then we're going to have both your x minus 1's cancel out, so you're going to have just a cx. So next, you're just going to have to simplify and go ahead and multiply out. Now if you have an a times x minus 1 squared becomes an x squared minus 2x plus a 1. Over here you're going to have a bx squared minus bx, and you still have just your cx. So then let's go ahead and distribute your a through here. So then we have a 2ax plus an a plus bx squared minus bx once again plus a cx. Now you need to group together anything that has an x squared, group together anything that has x's, and group together anything that has just a constant. So we're going to have ax squared plus bx squared. We're going to group these together because we're going to have to eventually take out an x squared. And then we're going to group together our x's. So we have a negative 2ax minus bx plus cx, because we're going to take out an x, and then we have an a here. So once we factor out your x squareds, that's going to give you an a plus b times x squared. We're going to factor out an x here, so it's going to give us a negative 2a minus b plus c, that's times x, plus an a. Now remember, this is equal to your original numerator. So then what we have, a 3x squared minus x plus 5, you actually have 3 terms, which means you're going to have a system of 3 equations. So we're going to group together AB, and we're going to set that equal to your 3. So we'll say A plus B is equal to 3. And then we're going to group together your next set here, your negative 2a minus b plus c, and we're going to set that equal to a negative 1 you have right here. So you have negative 2a minus b plus c equals negative 1. And then finally, you can put together your constants, which there's just a 1 here, so we're going to put a 1a, sorry, you're just going to say a is equal to 5. So the cool part is, now we have, by using back substitution, you can actually simplify and solve for a, b, and c. Well, we know a is equal to 5, so if we plug a 5 back in the very top, we can say that a 5 plus b is equal to 3, which means that b is going to be equal to a negative 2. And then we can plug our negative 2, our 5, into our middle equation here, and we can say that we're going to have a negative 2 times, whoops, wrong colors. Here we go. Negative 2 times 5 minus a negative 2 plus c equals 1, negative 1, and that's going to give us c is equal to 7. So now that we have all 3 of your numerators, you can rewrite your fraction up here. And for your a, you can say 5 over x plus your b, which is negative 2, over x minus 1, plus your c, which is 7, over x minus 1 squared. So that is how you decompose a partial fraction.